God, we thank you for this time. I pray for these students that you would bless them, help them to understand, and also, Lord, I pray that you would just bring peace upon this room. In Jesus' name, amen. Okay, so here is our lesson for today, 81. We're jumping into this exciting adventure. First of all, we are going to do some suffering today. Are you ready to suffer?
Yes.
We're going to suffer painfully. Now, we have learned two ways so far in order to solve equations. What are those two ways? Systems of two equations in two variables. Like this problem right here. Y equals x plus 1 and y equals negative 2x plus 4. What are two ways that we know how to solve these already? Number one.
You can just, send us the bottom one. Oh, wait.
What are they called? What are the methods called?
Substitution and elimination.
Substitution and elimination.
Alright.
So, if we were doing substitution, what would we do? Sierra.
We would plug in x plus 1 for y.
Excellent. X. Excellent. Okay, no, you did not joke. Laugh at my joke.
Oh.
Is it because you do not think it's funny?
It's absolutely brilliant.
I don't understand this one.
Okay, so y equals x plus 1, so I'm going to plug in x plus 1 for y and get that. Now, how do I solve from here? Next step? Sunny? Next step? We have x plus 1 equals negative 2x plus 4.
You
I just solved it.
do the.
Add, subtract, multiply, divide. I will subtract 1 from both sides and then add 2x to both sides. So you get on the left side, everybody,
3x.
3x. Wait, left side. Lefty, loosey, righty, tighty. What do we get on the Brooke? Don't look so angry. It's okay. There's the pattern. Follow the pattern. You've got the pattern. Just do the first 9 and then flip it and then flip it and then flip it more. You got this. There's a pattern. Okay. So 3x equals what's on our right side? We have 4 minus 1, which is 3. So x equals 1. Then you're going to plug that back into the beginning. Y equals x plus 1. If x is 1, y equals, everybody?
2. Oh.
1 plus 1, which is 2. So our answer is 1, comma 2. Now, that's substitution. That's not what we're learning today. There's also elimination. So if y equals x plus 1 and y equals negative 2x plus 4, if I multiply the second one by a minus sign, I get negative y equals positive 2x minus 4, and I can eliminate what variable? Which one will go away? X or y? Y, right? Because y minus y is 0, so my y's have been eliminated. Then x plus 2x is 3x. 1 minus 4 is minus 3. If I add 3 to both sides, 3 equals 3x, and we are not surprised that x equals 1, y equals 2, and our answer is 1, comma 2. But today's lesson is none of those. Today's lesson is the most difficult lesson to ever hit the likes of Algebra 1. Instead of solving by substitution, or instead of solving by elimination, we will solve by graphing. No. The solution by graphing is painful.
No.
So, how do we graph? Well, they've already given us the equations of these in y equals mx plus b form, right? We're comfortable with that. It gives us warm fuzzies. And we're like, oh, sweet, y equals mx plus b. So how do I graph these two lines? Well, how do I graph y equals x plus 1? I start at the y-intercept, which is 1, and then on my graph, I go up 1 and over 1. Why do I go up 1 and over 1? Because the slope in front of the x is 1 over 1. So, from my starting point, y equals 1, I go up 1 and over 1. Then I go up 1, over 1. Then I go
Up one over
thank
one.
you. And then up 1, over 1. And then I connect the dots using a straight edge. Without hitting myself in the head with a straight edge. That would have been painful.
That's it. So
And was very close. That's it. It was over. That doesn't even go through the points, but it's close. Okay, how do I graph the other one? Y equals negative 2x plus 4. I start at
the
the y-intercept, correct, which is 4. So I go 1, 2, 3, 4. Then I go, since the slope is negative 2 over 1, I go up or down 2? Down 2, because it's negative, over 1. So I go, start at the 4, go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and connect the dots. And get the splinter. That was unpleasant. On a scale of 1 to pleasant, solid 0. Okay. Do you notice something? The two lines cross. They cross at a certain point. What point is that? X equals 1, y equals 2. So the answer is 1, 2. Are we surprised? No, because using our first method of substitution, we found the answer is 1, 2. Then we used elimination, and then we found the answer was 1, 2. So if this is a legit method of solving, we should be able to graph the two lines and get 1, 2. Did we? Yes. So, happy campers? Yeah. Well, we don't like graphing, right? Because it's hard. Oh, wait. What does the Bible say about hard things? That we should avoid them and never do them? Oh, sorry. That's not how God works. So if you're like seeking the easy A, the easy out, the easy answer, I think you're doing Jesus wrong. Like, I think something's wrong if you're like, I just want the easy way, right? That's like our heart's desire. Is we're like, how can I do this easiest way and get me out of here? Now, sometimes that's okay. I don't think all the time that's wrong, right? But I think definitely there are some times when God calls us to do things that are difficult. Earlier this morning, God was putting someone on my heart. He was like, you need to talk to that person. You need to talk to that person. You need to talk to that person. I was like, okay, God, I'll text them later. And then later in the day, God was like, you need to talk to that person. You need to talk to that person. And I was like, okay, God, I'll text them later. And then you know what happened? So mad. They texted me first. I was like, I could have been the one. I could have been the one that was like, hey, how are you doing? Hope everything's going all right. Can I pray for you? No. They texted me and said, hey, how are you doing? How's everything going? Can I pray for you? I was like, I wanted to be the first one. If I had done it when God told me to, isn't that horrible? That's like so carnal in the flesh, right? If I had done it when God told me to, man, I would have been the first one. I would be praying for them. Now it's like, hey, call me if you need anything. I was like, so, anyways, listen to God the first time you want to start. Okay, let's solve this one now. That was a side conversation. They beat me to it because I was slow. I was lazy. Okay, we are now going to graph y equals 2 and y equals x. Let's talk about y equals 2 for a second. What's the deal with that line? Does it go up and down or left and right? Y equals 2. I'll give you a hint. The y-axis is the one that goes up and down, and 2 is right there. So does it go up and down? Raise your hand. Does it go left and right? Raise your hand. You raise your hand for both. That's unacceptable. Hands down. Up and down. Raise your hand.
I was stretching.
Oh. Left and right?
Yeah.
Everybody?
Happy camper.
No indifference allowed. Everyone must choose an option. We'll try it again. Up and down.
Raise your hand.
Stop stretching.
Oh, no, sorry. I was tired.
Left and right. Okay. This line, y equals 2, goes sideways. It's all of the points where y equals 2. So if you have like a little grid, right? You want all the points where it's 2 above the middle. That's it. Right? Now, that's y equals 2. What about y equals x? Well, let me add some information to you.
Y equals 2.
Well, something's going to be 2. We'll see. Okay. Actually, they'll both be 2. But when I see y equals x, I'm like, that's not in y equals mx plus b form. But I could graph it y equals 1 over 1x plus 0. And now that is in y equals mx plus b form. So where do I start? The y-intercept, which is 0. Then I go the slope. Rise over run. I rise 1. I go to the right 1. So I go up 1, right 1. Up 1, right 1. Up 1, right 1. Then I connect the dots using a straight edge without getting a splinter. Splinters hurt. So, where do they intersect? Right here. What is that point? 2, 2. X coordinate goes first, then the y coordinate. All right, now we have an issue.
Uh-oh. The issue.
Let us, not the vegetable, try and solve this problem here, this here problem. We are to solve y equals x plus 2 and y equals x minus 1. Now, here's what I would like you guys to do. This section here, you will solve by elimination. Go. This section here, Daniel and Daniel, you must solve by graphing. Good luck. And this section, Riley, Kira, and Sierra, you must solve by substitution. Go. Solve this equation. Y equals x plus 2 and y equals x minus 1.
Y equals x plus.
Riley, to the office, please. Today, Thursday. There's nobody in the office. What's that going to do? I don't know.
So much together.
All right, have you guys encountered a problem yet?
Yeah.
Yeah. Did you find out that 2 equals negative 1?
No.
Or like 1 equals 0?
Yeah.
Okay, so the elimination group got 1 equals 0. The substitution group, what'd you guys get?
0 equals 3.
You got 0 equals 0?
Yeah.
Nobody's there? Oh, you got it.
Just me.
We're gonna take the next one.
Okay, cool.
Y equals 2. Wait, no. Wait.
Okay,
3x.
so
I got 3x.
here's the problem. Are you ready? If we use elimination, we make the second one negative, and you get, hi Riley, 0 equals 3. That's wrong.
Yes.
Okay? Sorry. 0 does not equal 3. Now, let's use substitution. If you substitute the first one in, x plus 2 equals x minus 1, then you get 2 equals negative 1. Is that true?
No.
No. That's wrong. So, here's the key. These show us that there is no solution. So our answer would be no solution. And the reason why is because they are, and you have to memorize this, so write down this word, they are inconsistent. Inconsistent. How do we know that they are inconsistent? First of all, we had this like weird thing, right? 0 equals 3 popping up. But you'll also notice that the slopes of these lines are what? They are both 1. So you have an inconsistent equation, and I'll graph these for you guys, when the two lines are parallel. So if the two lines are parallel, they will never cross, and they are inconsistent. So if I give you a system of two equations and two variables, and it says solve by graphing, and you find out that they're parallel, then your answer should be that they are inconsistent. Now, what about this? We also have equations that are like this one. Y equals x plus 2, and 2y equals 2x plus 4. Okay, how do I solve that one? Yes, Sierra.
You have to convert the second equation to slope-intercept form.
Okay, cool. I'm going to convert the second equation to slope-intercept form, and something bad's going to happen. So I'll divide everything by 2, and I get y equals x plus 2. This is awkward. So I converted it to slope-intercept form, and I found out that it's exactly the same equation as we started with.
Done.
Problem?
Done.
Well, yeah, it's a math problem. Sierra, I skipped a page, by the way. So we're on 333, if that helps you. Sorry, I jumped. Okay, cool. We're on the same page. Literally. Okay, so when you have the same line, check out what happens to our solutions. I will now graph the first one. Are you ready for this? Yeah. Okay, I graphed the first one. Now I'm going to graph the second one. It's the same line. We already knew that. That means that all solutions are possible. There's an infinite number of solutions, right? I could plug in 1 for x and get 3 for y. I could plug in 2 for x and get 4 for y. I could plug in 5 for x and get 7 for y. There are an infinite number of values for which y equals x plus 2. And so, if we get this, these are called dependent equations. So, you would write, they are dependent. And what's your answer? God bless you. There are an infinite number of solutions. So, everything in that circle, dependent, and then you would say there's an infinite number of solutions.
That's crazy.
Yeah, why? Because it's the same line. So, we have inconsistent, we have dependent, and then we have consistent ones. Those are just the normal ones, where you solve it and you get one answer. So, sometimes they'll ask you to categorize these. You have 3 options. Consistent, where the 2 lines cross and you get one answer. Inconsistent, where the 2 lines are parallel, they have the same slope, and so you get no answer. And dependent, where the 2 lines are the same line, and they are an infinite number of solutions. So with that said, let's try one more example problem. This is example 81.6. Okay, so we are going to consider the equation y equals 2x plus 5.
There's still more? Oh, wow.
and y equals x. Is this consistent, inconsistent, or dependent?
Dependent.
Now, I'll give you the trick. If the slope is not the same, it's consistent. They will always cross. This one, 2x plus 5,
It's consistent.
2x plus 5 looks something like this. You go up 5, and you go up 2 over 1. And you get, ugh. Okay.
Ruler.
And then y equals x looks like this. Oh, I should have gone further. Yeah. So,
It's a bird.
as long as the slopes aren't the same, if the slopes of your lines are different, it's going to be consistent. If the slopes are the same, you have to decide whether it's the same line or if it's two different lines. How do you figure that out? If the y-intercept is different, then you could have, so like let's say this was y equals 2x plus 5 and y equals 2x plus 1. If the y-intercept is different, you get what? Inconsistent. If the y-intercept is different, but the slope is the same, you have inconsistent. If the y-intercept is the same and the slope is the same, you have dependent. But it only works if you have it in slope-intercept form. So that is your